everyone, this is Trevor May, VRF Technical Specialist here at Standard Air Lite. Today we're going to be talking about the VRF product overview. So this overview is essentially going to cover both of the VRF systems that we carry and support, and then some more information on what those systems do, and more importantly, why do we have two different types of VRF systems that we deal with. So quick agenda. First thing we're going to focus on is our VRF system type. So heat pump versus heat recovery, how to differentiate between the two. More importantly, to understand that there are two different types of VRF systems, that they're not just all simultaneous heating and cooling, and that will depend on the application that we're looking at, whether that be a residential application, a light commercial application, or a traditional commercial application. We're then going to transition into our carrier product overview, which is our two-pipe, or commonly referred to as our two-pipe system. We'll then transition into the Toshiba carrier VRF product overview, which is commonly referred to as our three-pipe style VRF system. And then finally, we'll conclude with some notable VRF jobs, for what I call VRF job profiles of currently installed equipment at various job sites throughout our area. So, two primary VRF system types, both on the carrier and the Toshiba carrier product line, is first and foremost the heat pump. Heat pump is just like any traditional commercial split application. So this is going to be all heat or all cool, and not simultaneous, just like a traditional heat pump. So this allows for the span coils, providing either cooling or heating based on that outdoor unit's mode. And then switching over to heat recovery, which VRF is most notably known for, is the simultaneous heating and cooling. So we allow the fan coils on the indoor unit to provide simultaneous heating and cooling by thermal zone when operation temperatures are permitted. And essentially what that means in a nutshell is we can have one unit of heat, one unit of cooling, and we'll get into how that's possible here very shortly. Okay, but it's important to understand that both of our systems, the carrier and the Toshiba carrier, have a heat pump and or a heat recovery option. So when we look at the basic system breakup of a heat pump style system, so this could be on our carrier or Toshiba carrier heat pump product, the exact same system layout will stay the same. We have an outdoor unit, an indoor unit, and then some form of control. So our outdoor unit, of course, is going to house our compressors, all of our electronic components, outdoor coil, outdoor fan mode. Then we have our interconnecting refrigeration pipe. It's going to feed to one indoor or to be multiple indoors, depending on the application. We have high wall units, as you see here. We have a set unit picture, conducted units, vertical air handling units. There are a wide variety of indoor units to choose from, of course, because there are a wide variety of applications. But essentially, the indoor units are going to allow us to transfer that heating and cooling into space and essentially become that zoning feature throughout different areas of the application that we're trying to deal with. And then finally, some form of localized control, whether that be a wireless remote control or what we see here with a wired remote control. Now, of course, we always have centralized control options, and we also have the ability to integrate into building management systems that are BACnet native, that work with LawnWorks, and that also have existing IV or looking to apply a carrier IV control system. We can integrate the VRF into that IV control system as well for seamless control. So really the possibilities are endless on how we can apply and also integrate controls into a commercial or light commercial structure. Now this is where we start to change things up. So with the carrier or the system that's referred to as the two-pipe heat recovery system, we have our outdoor unit, our indoor unit, some form of control, just like we did on the heat pump system. But now what changes is what we call our MDC. And some people call these flow selectors, some people call these branch boxes. They're essentially doing the same thing, but they have different acronyms and names or identifiers to break them up depending on which manufacturer that you're dealing with. On the carrier side of things, we call them our MDCs, or a multi-port distribution controller. And this essentially is the part behind the heat recovery system. This box is made up of three main components: the gas liquid separator to separate refrigerant into two states if you have a simultaneous call, so it's heating and cooling call. We have solenoid valves, which will open or close based on whatever that particular indoor unit needs, whether that be heating or cooling. We have a very strange heat exchanger that helps subcool liquid refrigerant so that we can pipe great distances from these boxes. And these boxes can get roughly upwards of about 220 feet. Okay, but essentially what this box does is it reverses the refrigerant flow to the indoor unit depending on which one of those units are calling. And again, as I stated before, this allows that simultaneous heating and cooling for using a byproduct of one zone where we would traditionally vent out to the outside. And we're not going to use that byproduct to be able to provide heating and cooling as needed to be energy efficient and also meet the needs of the user. Okay. So when we talk about the carrier being the two-pipe heat recovery system, that's because we have two pipes feeding from our outdoor unit. Okay. Suction line, phase line, depending on how that system's operating. Now, the reason that we have two pipes on this is two pipes feed in, and now we get that gas liquid separated. Okay, so on this system, that separation process into three states of refrigerant, so hot gas, liquid, and suction, happens within that NDC. And you'll see as we talk about the Toshiba carrier system and where the differences are. But the heat pump system, of course, has two pipes as well. The only difference between the heat pump system would be the fact that it does not have an NDC, a range box, a flow selector, whatever you want to call it. It does not have that item that allows, that's not an NDC. Okay, so when you look at the carrier system, the heat exchange process for the heat recovery happens within that multi-port distribution controller, separated into three different states of refrigerant: hot gas, liquid, and suction. Okay, so looking at the Toshiba carrier, so same thing as we have with our carrier system. We have an outdoor unit, we have a flow selector box, or NDC, or branch box, whatever terminology you're comfortable with identifying that box as, an indoor unit in some form of control. Now the difference is if you look at this Toshiba carrier system, you'll see, commonly referred to as the three-pipe system, on this flow selector box, right here we have three pipes, which means we have hot gas, liquid, and suction going in and leaving the box depending on how that system is operating. Okay, the biggest difference between the carrier two-pipe and the Toshiba carrier three-pipe is that on the heat recovery systems, that outdoor unit for the Toshiba models is where that heat exchange for that separation process takes place. Hot gas, liquid, or suction. And essentially all that happens in that outdoor unit is a solenoid valve on the hot gas line opens up and bypasses that outdoor portal where we send it in a cooling mode. And now it redirects it directly to the hot gas line, which leaves our outdoor unit and feeds into this flow selector box. So that separation process on the Toshiba carrier happens at the outdoor unit, not at the flow selector box. Okay. Now on our flow selector boxes, since we have three pipes feeding into it, we don't need a gas liquid separator like we did on the carrier system. So these boxes are made up of two main components: solenoid valves that open or close depending on what indoor unit is calling for what, whether it be cooling or heating. And we also have a 2-in-2 heat exchanger, which again, just like in the carrier system, subcools that liquid refrigerant so that we can get greater heating distances from this box. Now, the other differences between the carrier and the Toshiba carrier outside of where we separate that refrigerant in different states is with these flow selector boxes in the Toshiba carrier system, we have two different selector types. As you can see here on this slide, we have a single port box and we have a multi-port box. So depending on the configuration of that system and how we want to lay it out, we have a little bit more flexibility on the selector box types. So one of the biggest advantages of using a single port box is that we provide power and communication from the indoor unit, which means we don't have to run a separate power source or communication wire, because those bundles come with that flow selector box to automatically hook up to that indoor unit to power it, and also to be able to communicate with the indoor unit as a heating or cooling call to a solenoid can open as needed. The other unique advantage with this is that this does not require a ring. So if you're in a space that is tight, that needs something to compact, and not you might want to take into consideration. But of course, we have our multi-ports as well, and we'll get into some of the different designations of when we use a single port and we use a multi-port as we go throughout this presentation. Okay, but as a rule of thumb, when we're looking at comparing associated carrier to carrier, we now know that the carrier system separates in 3 states of refrigerant and C multi-port distribution controller on the heat recovery system. And the Toshiba carrier heat recovery system separates those in the 3 states of refrigerant and output. Now, this is where I want to get into talking about calling the system a 2-pipe versus a 3-pipe system. Now, that would be correct on the heat recovery side of things because, again, that's where that separation process takes place or how you label those. But both of these systems have a heat pump option, as I stated before, which means that this is just a strict heat pump option. We're not going to have a flow cylinder. We're going to have an outdoor unit, an indoor unit, and some form of control, which means this system that is commonly referred to as a 3-pipe on the heat recovery side of things is actually now a 2-pipe system. Okay, so it's a little bit confusing on when we talk about 2-pipe versus 3-pipe, what that all actually means. The best rule of thumb that I can give you guys would be if you're talking about the Toshiba carrier system, you need to designate whether it's a Toshiba carrier heat pump or a Toshiba carrier heat recovery, which is going to dictate how many pipes you have. And then, of course, if you're dealing with a carrier product, it's going to stay the same whether you have a heat pump or heat recovery in terms of 2 pipes from the outdoor feeding into the building. Now, if it's a heat recovery, you'll feed into a flow cylinder box. If it's not heat recovery, you'll flow directly into the building. Okay, so rule of thumb, Toshiba carrier in the 3-pipe style systems is what I prefer them to be referred to as, just to eliminate confusion. The quote-unquote 2-pipe styles referred to as carrier. And of course, differentiating whether you need heat pump or whether you need heat. All right, so let's go ahead and take a look at the carrier product overview. So with the heat recovery side of things, so this is going to be that simultaneous mode, we have a unique advantage with these configuration of outdoor units. You can see here we refer to these boxes as modules because they offer a single base rail capability, which means we do not require twinning kits as we start increasing certain tonnages. For example, if we were to look at the Toshiba carrier system, when we go to 16 tons on that system, we have 2 units that are twinned together to equal that capacity, 2 6-ton units. So when we're looking at carrier product, our small box module will range from 6 to 8 tons, and they'll offer 1 compressor per outdoor unit. And depending on the tonnage we're working with, we'll dictate the total number of indoor units that we can connect to that system. So it's certainly important to reference this chart, and if you don't have some referencing material in front of you when you're looking at the chart, I always suggest that you reach out to me via email, phone, anyone here at Standard Air Lite that can advise you the maximum connectable indoor unit number so that we're not designing a system that will not be able to work. So as we increase to the middle box module, this will range from 12 all the way up to 20 tons. And now we're adding 2 compressors in. So we're going to get a little bit greater efficiency because we have that second compressor, and that also adds some redundancy. And just like we had on the small box module, as we increase in tonnage, our total maximum connectable indoor unit quantity will increase as well. And then finally, our large box module, which will range from 20 all the way up to 28 tons, which is the maximum tonnage heat recovery system. We now have 3 compressors, which we get greater efficiency because we have that third compressor. And just like before, as the tonnage increases, the total connected indoor unit quantity increases. So we talked about heat recovery operation temperature. In the cooling mode, we can go down to 5 all the way up to 125 degrees. And in the heating mode, we can operate all the way down to -13, all the way up to 64 degrees. Now, mind you that these ratings are just guaranteed performance ratings for AHRI. They can run below this, but please keep in mind as we get lower in the heating mode, hotter in the cooling mode, the potential that we either pick off a low pressure or a high pressure load. As an example, too, we'll see -13 for heating. nominal capacity. So again, this varies based on the tonnage of the outdoor unit. So we look at those heat recovery modules, whether we have single, dual, or triple, because of the amount of compressors in, and also the coil surface area. The other factor that plays into that as well is the connected capacity. So how many indoor units, percentage-wise, do we have connected versus the outdoor unit? So if we have an outdoor unit with indoor units, that's 100% connected capacity. And that also factors into the PV rate that we're looking at. So for example, if it's 80%, it's only 6 tons. It would vary based on the application. So there's really no cut and dry way to give you a chart that would say, okay, a picture going to give you this much here. And that's why we have our room design software, which essentially allows you to put in different design conditions and build the system out so you can see exactly what that PV rate would be for that particular area, for that particular. Okay, so we talked about heat recovery. Now let's look at the heat pump side of things. So with the heat pump side of things, we no longer have that single base rail, and now we get into the single, the twin, or the triple module, depending on the tonnage that we need for that. On the single module, for the 6 to 10 tons, we have one compressor, and again, on the heat recovery system, as we increase in tonnage, our maximum connectable unit capacity becomes greater as well. Now on the single module, when we move up to the 12 ton, we now add a second compressor, which does increase heating performance and also have that redundancy with that second compressor. As we increase in tonnage, we can start at 168,000 BTU and go all the way up to 238,000 BTUs on our twin modules for 2 units together. And then you can see on there from 168,000 BTU all the way up to 240,000 BTU. We have 2 compressors. And again, as we increase in tonnage, we have connectable quantity becomes. Now, as we get to the 264,000 BTU, we now have 3 compressors, which is going to increase that heating efficiency. And as we increase to a 288,000 BTU unit, we now have 4 compressors, which is going to increase that heating efficiency and also. And finally, for the extremely large tonnages, we have our triple modules, which will range from 12,000 BTUs all the way to 432,000 BTUs. See on there the 312 all the way up to 360,000 BTUs off the 3 compressors for a total of 384,000 BTU model, 4 compressors, our 408,000 BTU model with 5 compressors, and then finally our largest tonnage, which is our 432,000 BTU model, which has 6 compressors. So heat pump operating temperature ranges. So for the cooling unit, we can operate all the way down to 5, all the way up to 125 degrees. And then for our heating mode, we can operate down to -5, all the way up to 64. Remind you the same rule applies to the discussion with the heat recovery side of things. This all is derived based on whether we have a single unit, in this case for heat pump, twin or triple unit, and then the connected capacity compressor and coil surface area. As a rule of thumb, with the 6-ton system in there at -5, where it's 80% of that nominal heating capacity on that 6-ton model. But again, please take that with a grain of salt. That's why we have our room selection software, so we can calculate D rates on a job-by-job basis. That just isn't cut and dry to give an exact number for every single piece of work. All right, so we talked about the heat pump and heat recovery on the side of things. So let's look at our MVCs, flow selectors, branch boxes, or essentially the heart behind the heat recovery system. So we need to understand, one, terminology, which is the branch box. But two, we need to understand really what is the purpose of this new do. First, it's going to receive superheated gas and subcooled liquid coming from our outdoor unit. It's going to allow for the indoor unit to be in either a cooling or heating mode for that simultaneous operation, or what we refer to as heat recovery. And finally, it's going to distribute the amount of refrigerant via solenoid valves to the indoor units based on what they're calling for, whether it's heating, cooling, or a simultaneous heating and cooling. So you can think, or you can see it, you can see the top is completely removable, which means this box is servicing. So the solenoid valves that you see there with the different red, white, black, and blue colors on there, if one of those for some odd reason would fail shut or fail open, you don't have to braze to replace that actual electrical coil. It's not something that's caught up in the solenoid, it's not operating properly from the internals, that's a different story. But if you have an issue with that coil trying to open that solenoid or close that solenoid, all it is taking one Phillips screw here, taking that off, lifting the coil off the post, sliding the replacement coil on, taking down the Phillips screw, and then plugging in the electrical connection at the board, and that's it. It certainly is serviceable and easy from a contractor standpoint. Okay. But when we break this box down, we stated that there are three main components. The gas liquid separator, which of course is pretty straightforward. It's going to separate hot gas and liquid depending on whether we have simultaneous mode or whether we're running all heat or all four. We have our raised frame heat exchanger, which helps subcool that liquid refrigerant so we can make great distances with this box. And then finally, we have our individual solenoid valves, hot gas, liquid, and suction solenoids, depending on what indoor units are doing. Nice unique advantage and that we have with this box being fully serviceable. The other VRF manufacturers typically insulate this entire box, which means they don't have to have a drain port, which often is a nice selling feature depending on where you're locating this box. Typically, what you'll see is there's extra ports on competitive products that are left open because if it does fail, they can't get any access and replace the solenoid box. So they have to leave an extra port to the unit has failed solenoid valve and move it to the extra port that they left during the design. With us, you can go in and directly replace individual parts without having extra ports. And you can require a drain, however, that drain comes at a very cheap cost given the fact that you have to get in here and work on this box inside of it. Solenoid, typically we don't see that, but it is nice to have that serviceability and accessibility with the same. All right, so let's switch over to our indoor unit lineups. So with the two pipe range carrier products, we have our cassette style units. So if we work from left to right, top to bottom. We have our compact cassette, which is in our far left. That is a 2x2 design. To the right of that, we have our 3x3 cassette style unit. Now, of course, the compact is going to be limited on capacity because of the physical size of it, while the 3x3 cassette is going to have more available capacity because it's a larger physical construction, which we can get a large coil. We have our one-way cassette, which we see right here above our high wall unit, which is a new product, which we'll kind of get into the slide to talk about. We have a traditional high wall style unit, which most people are familiar with. We have an outside air processing unit, which essentially is going to act like the DOAS, so to speak. Again, take a grain of salt. Good rule of thumb is when we're introducing outside air to this, and outside air must be pre-treated and brought up to at least 32 degrees during the winter time, especially in the Pittsburgh area, because it can get quite cold. You need to make sure that air is pre-treated. But essentially, this acts like a makeup agent where we're finding a nice neutral air in the space to meet local constraints. We have a vertical air handling unit, which is located and also have backup electric heat options. Bottom left there, we'll see our under ceiling or our floor console unit. So this is a full purpose unit. It could be configured as a floor console, as we see here, or it could be configured as an under ceiling style indoor unit. So it's dual purpose. We have our floor console to the right of that, which is the recessed type. So we have a type that's set on the window sill right by window to help create that barrier. We have a replacement for that as well. And we have our ducted options. So working from left to right, we have our low static unit, which is going to offer up to 0.2 inches of static pressure. To the right of that is our mid static unit, which is going to get up to about ½ inch of static. And then finally on the right is our high static unit, which goes all the way up to 1.1 inches of static. So all in all, we have 11 different indoor unit types. They'll range from 5,000 all the way up to 96,000 BTUs. Now, of course, that depends on the model that you're dealing with. That doesn't mean every indoor unit has 5,000 BTU capability. It just ultimately depends on what style of indoor unit you're working with. very single phase application and have integral ventilation and condensate flow, making it one way to the models. So, for example, the compact and 3x3 cassette for the traditional style cassettes have outside air knockout, so we can pre-treat outside air and put them directly into that cassette style unit. And both of those have a condensate lift with a different lift rating that we can remove that condensate out of it, either to a secondary condensate pump or to a natural drain. The high wall and the one-way cassette do not have outside air intakes except for a specific range of temperatures on the one-way cassette short. Our outside air unit does not come with a condensate lift, and of course, we're mixing in outside air after it's been pre-treated directly into the returner. So if you are looking for condensate management on this unit, you need to make sure you specify that you need a condensate pump such as a dye, Solomon, etc. For vertical air handling unit, that's the same concept. There's no condensate lift built into it. It's going to require an external pump just like we do with a residential application. And you can always mix in outside air at the return. Sure that outside air has been pre-treated. Flow console unit does have an accessory condensate lift, but it does not come with the indoor unit from factories. We need to make sure if we are specifying that we need a condensate lift, that we do so on that model to be sure that we can improve the flow. Of course, now outside air can be ducted into either one of the four. And then we have our ducting units. Our low static is going to have a built-in condensate lift. Our mid static is going to have a built-in condensate lift. Our high static is not going to have a built-in condensate lift. So it's important to know on the high static unit, we're going to need an external pump. All three of those have outside air for ventilation mixed in at the return, but that air again does not be. So with our one-way cassette, this is a new product that we brought in, I think it was 2020, might have been the beginning of 2020. This will range from 5 all the way to 24,000 BTU. That's a one-directional airflow with multiple fan speeds. Now, I mentioned briefly that certain tone range on here actually had an outside air knockout and introduce outside air into. That's going to range from 15, 18, and 24,000 BTU models have that knockout for outside air. Again, must be pre-treated, but it certainly does offer some versatility of the 15,000 BTU model. And of course, just like every other indoor unit that we have on here, we have our flared refrigerant pipes for connecting us into the VRF. All right, so let's talk about controllers. So with our controllers, we have localized controllers, centralized controllers, and then upper-level controllers. You can see here working from left to right. We have our traditional wireless handheld remote control. To the right of that, we have our non-programmable wired control. To the right of that, we have our programmable wired wall control. And then finally, to the right of that, we have our touchscreen centralized control. So, with our programmable wired controller, just like any other local control in the VRF system, this has your temperature adjustments, temperature changes, load changes, but this also has the ability, of course, to be able to schedule and do any technical data such as temperatures, if the unit is currently running, some addressing, addressing from here, so it's much more than just a wall thermostat, which is why it's called a wired. If we look at the centralized controller, of course, this is going to be used in central locations for the entire system. So we have 3 different levels of account management, and it's set up to 20 different users with 2 administrators and 18 normal users, depending on the application that we're working with. We also have the ability for remote access via it's set up with an IP address so that you can dial in remotely to the centralized controller if you're not on site. You can set up alarm notification via email, fire alarm, and interacting information with 4 visual input and visual output. Next part of this is you don't have to essentially write a program and send it to the centralized controller. When we have everything hooked up, all we do is tie 2 wires from the centralized controller into the outdoor unit, and then hit the auto search when we're configuring this, and this automatically recognizes all of systems that are hooked up to the centralized controller, which really makes it seamless for control integration. We can control 384 indoor units totally between multiple systems. And then, of course, control, we offer mode settings, fan speed settings, set point display, speed settings, dual set point control, set temperature range limiting, with air flow display and port ventilation. We can set up clock and weekly scheduling. So this certainly is larger jobs, almost a crucial piece, I would say, to be able to monitor, control, and ensure that that system runs to its efficiency at all times. And if it's not, to be able to have something that we can generate error codes, system reports, integrate with other building controls, and local codes, so we can access from a centralized or for remote location. One unique piece that was added beginning in 2020, working on the same point that one way said was our VRF DLS Interface. Oftentimes, what we've seen, and also what carrier is seeing, is that you have a VRF job, but you also see a lot of ductless equipment. What better way to make control seamless if you can tie both the VRF and the ductless equipment on one centralized interface? That was the reason that this product was developed and introduced, so that we can have that seamless control between ductless equipment and the VRF equipment. So essentially what this ductless interface does is it takes the ductless protocol, if you will, sends it over to this ductless interface, converts it over into a protocol that the touchscreen controller can interpret and display, just like we have with the carrier VRF system. It's important to note that this interface that we see here, this gray box, you must have one per ductless indoor unit. So you can't have 5 indoor units reporting back to one box. One per indoor unit, but we do have the ability to integrate in and have that centralized monitoring and control, not only of the VRF system now, but of the ductless system. Now, commercial projects, that certainly is a great advantage. One thing that I commonly get asked on these VRF and ductless interfaces is if this can bring us into BACnet, and that is not the case. This device will not convert carrier protocol over to BACnet protocol. We do have a specific BACnet interface that was recently introduced for ductless indoor units to bring them on to BACnet native system, but this VRF ductless interface would not be the device that we're looking for. As we get into upper level control through the BACnet over IP interface, essentially this converts that carrier VRF protocol over into BACnet protocol, and also has a built-in centralized controller access via LAN cable, and typing in the device's IP address into an internet browser, and be able to see all of our indoor units. Okay. When we integrate, we get our indoor unit information such as temperature set, indoor temperature, operating mode, air flow, and depending on the mode that we want to set. And with the outdoor unit, we get the mode, the outdoor temperature, and air flow. We have 4 ports available on this device. Each port can access 64 indoor units or 8 refrigeration systems. Okay. So if you're not directly tying into a BACnet system, or you're going to eventually tie into a BACnet system, this is certainly a device to have on you, because via link, which you can see right here, the plugin, plug this into a localized computer and open the IP address that this device has. You can now log into the device via the computer and has the built-in centralized control. This also has a various amount of points that we can integrate into depending on the job and what points you're looking for. Okay, so we talked about our control, so let's look at the heat pump line segments. Okay, one thing to note on here, I'm not going to go through every single line segment as far as vertical distances and horizontal distances. I mentioned that we have our room software. The whole reason the room selection software was designed to carry VRF systems was to be able to take the best work out of getting over my maximum. So when we're laying out jobs, while it is nice to have this as a reference of the each VRF job that is done by Standard Air Lite must be built in software and either seen by me or my direct boss to ensure that it is approved before it gets quoted out, to ensure that we'll have a nice, seamless job that we're not going to run into misapplication, or if we're not going to work with each other, or if we're exceeding the piping rate distance. So the generalized rule of thumb our total system piping length for a heat pump carrier style system is 3,200 feet. Same thing applies with heat recovery in terms of running the application. As a general rule of thumb, the total length from this system that we can operate with a variable heat recovery system is 2,640 feet. And then finally, just covering some advantages before we transition over into the Toshiba carrier side of things. The advantage that we have over the other two pipe systems on the market is going to be we don't have called hub and spoke. So what we have is our outdoor unit. We have our communication bus that has a small plug that will wire in directly to this MDC and then hardwire in the X and Y terminal on the outdoor unit. If you have a centralized controller, if you don't, it's the wire directly into the G. Okay. Always wiring this into PPG. Hooking up X and Y if we have a centralized controller. If we don't, we just leave it alone. Okay, so now we've established outdoor unit communication from outdoor unit to MDC. Now we have hub and spoke. So depending on the amount of ports that you have on the box, in this case our smallest box is a 6-port, we have each individual PPG port 1, port 2, port 3, port 4, etc. All you're doing is going from port 1 PPG on port 2, indoor unit 2, port 3, indoor unit 3, etc. So now we don't have that daisy chain that's going to come across here, which can often be miswired. Essentially, you can follow and take your control wire to follow your equipment right directly to that indoor unit with that hub and spoke style communication wiring, which makes the wiring of the system simplistic. And finally, I talked about the heat recovery systems having a single base rail and the advantages that offers over other manufacturers in the market. So we can see here, as we go to certain countries, other VRF manufacturers require a twin kit, which, if not done right, can start an oil back to the compressor, velocity, push and turn, that's simple operation. And you're also using more copper, more installation time. Through the product, we have our single point piping and single point electrical, which means we have one unit, we only have one source of main power, one source of communication, two pipes coming up. They're twin kits. It saves on material and labor to install the equipment, and it also cuts down the complexity of having the twin kit for other VRF manufacturers. All right, so we talked about the two-pipe product. Hopefully, we have a better understanding of what that two-pipe product or that carrier product is about. Now, let's take a look at the three-pipe product, or what we talked about before, is the Toshiba carrier product. So, with the Toshiba carrier product, the easiest way to differentiate if you just look at the face value, we have our SHRM series, and we have our SMSE series. Just way to pick them apart. The HR is heat recovery, or that's simultaneous. If it does not have an HR, it's a heat pump. So with the heat pump and the heat recovery models, we have 21 different unit sizes and configurations that we can work with depending on what kind of unit for that job. Will range from 72,000 all the way up to 456,000 BTUs. What configuration we use, as you can see above, whether we have a single or triple configuration. These are available for 208, 233 phase and 460 volt 3-phase application. And we have a 50% to 130% connected capacity limitation on there, and you can get up to 150% with carrier factory engineering improvement. Okay, good rule of thumb is if you don't understand what connected capacity is, if we look at 50% capacity within the absolute minimum that we have connected. So we have a 6-ton outdoor unit. And we only have 3 tons of outdoor units that we're connected to it. And that would be 50% connected capacity. 100% connected capacity would be a 6-ton outdoor unit, 6-ton indoor units. And of course, as we go above, let's say 7 tons, a 6-ton system, we start looking at 115% capacity. what we're talking about in percentage, the amount of indoor units that compare to the total tonnage of the outdoor unit. So 50% or half of the tonnage of our minimum, up to 150% connected capacity with factory approval. But again, when we look at our load balances throughout the day, especially when we're going above 100% connected capacity, make sure that we're not shooting ourselves in the foot and we don't have enough capacity for the worst condition that we would have in the hot portfolio. So with these outdoor units, for each individual outdoor unit, we have two rotary compressors per outdoor unit, which have the dependency between equal runtime. And also we have protocol boards that look at compressor runtime so that we can balance the total runtime of the compressor between compressor 1 and compressor 2, which generates a longer lifespan because they see equal wear. So with our single module, we'll range from 6 all the way to 14 tons. So this will just be 3 pipes out of the machine itself. Okay, if we have the heat recovery, if this is just a heat pump, remember, you only have 2 pipes. Okay, 6 to 14 tons is the range for a single module. For a dual module, or beginning with a twin kit, will range from 16 all the way to 28 tons. Now you'll see on here on the 16, 20, and 24 ton machine, we have an S in the module. That S is for a space saving configuration. For example, if we have a 16 ton space saving unit, let's just say that an 8 is typically what we use to move those 6 tons that we're taking 2 units to put them together. Well, instead of using an 8 ton unit and an 8 ton unit, we may use a 3 ton unit, 6 ton unit to take up less physical footprint if we're dealing with an application that has those limitations as far as area that we can put the unit in. So on the 16, the 20, and the 24 ton unit, we have those space saving configuration, which essentially is playing around with all of the available capacity of a single module, allowing them to get the same tonnage, but it's become less and less. And then finally, with the triple module, we'll range from 30 all the way up to 38 tons, and only on our 34 ton machine do we have that space saving feature. Okay, so we look at heat recovery and our heat pump temperature operation range. So in the full mode, we'll operate all the way down to 14 and all the way up to 115. In the heating mode, we can operate all the way down to -13, all the way up to 60 degrees. And we're offering 70% of that system's nominal capacity at -13. And like I stated before with the carrier product, this is all dependent on whether we have a single, dual, or triple module. The amount of coil surface area, the amount of compressors that we have available, and also the connected capacity, whether we're at 100%, 110, 70%, so that completely varies in the 70% capacity based on the 6 ton module. With our heat recovery, piping lengths, and also with our heat pump, again, we have our own software, so we don't have to remember these numbers off the top of our head. While they are nice to have as a quick reference, that group selection software has these numbers built, so as well, that as you guys are working with us laying out a job, you can rest assured that we've met our minimums, we haven't exceeded our maximums. And as a general rule of thumb, total piping length is 3,280 feet for to achieve a carrier heat pump. So it's looking at the single port flow selectors on this. We talked about this system having 2 different types of flow selectors. Our single port are going to be sized based on the amount of capacity that's connected. So we'll look at anything below 38,000 BTUs connected to the single port box. That's going to dictate the long window that we have. As we step up, as we range between 38 and 61,000 BTUs of capacity connected to it, we're going to get a separate box. And then finally, on larger tonnage applications, 61 to 96,000 capacity, and with a maximum connectable capacity. Okay. And as I noted before, if you look on the bottom selector box here, we see this little whip that comes supplied with the flow selector. This whip comes with this. All this is a communication plug that plugs into the indoor unit for communication so that these two can work in unison. Same thing goes with power, so that we can use power from the indoor unit out of this box which is one of the advantages of using this box. And of course, as I stated before, the other advantage with this box is that it does not require Ethernet. It's compact, it's power and communication, it's corresponding indoor unit. So we talked about flow selectors in the back in the look where it says 8 indoor unit max capacity on this unit. So we talked about single port flow selectors. Okay? This single port flow selector, flow selector curve. Okay? So this has two main components: a tube to heat exchanger and cylinder valves that open or close depending on what mode the indoor unit that is connected to it is calling for. So, as a rule of thumb, this box can only give you in the heating mode hot gas, advance it down to the liquid, and return the liquid. Or if it's in cooling, we can only give you the liquid, boil it off into a suction gas, and then send it back. So, for example, if we have 3 indoor units connected on this one box, and let's just say the high wall unit that we have at the very top here is calling for heating, and it's calling for cooling. This system from the factory is set up as a heating priority. Now, this is configurable. You can set these for cooling priority depending on the physical location you're at. But as a general rule of thumb, these come set up as a heating priority, which means this unit up here is going to run for heat, while these 2 units down here are just going to sit and stand by, which is going to create some uncomfortable situations for the guys or girls in these particular areas. And it's important to know the system's not going to automatically switch over to run a cooling call for these. These all have to be in cool or all have to be in heat. So it's important to know that these units, while they can have 3 on one single port flow selector, need to experience the same thermal demand. Essentially what that means is either all in heat at the same time or all in cooling at the same time. If you have a situation where this one needs cooling and these 2 need heat, or vice versa, these need to be on their own individual ports, either through individual selector boxes or we select a multi-port flow selector box, which allows each indoor unit its own individual port or selector. So we talk about the flow selector per zone. These are all experiencing the same temperature, which may be a problem. But if you have those diverse thermal loads, that's when you can start running the issue with expectations versus what the actual equipment can do when we're looking at a single port box. So moving over to the multi-port box, these are available in 2 configurations. As you can see here on this slide, we have a 4-port configuration and a 6-port configuration. So with the 4-port configuration, you can see we have 4 ports and generally we have 2 more things. Solenoid valves, double pipe heat exchanger helps subcool that liquid refrigerant. And we have multiple units that experience different thermal loads connected to one flow selector branch box, or see however you want to refer to it. And what we're doing essentially using refrigerant as a medium is taking the excess byproduct of whatever the dump is. Let's just say, for example, we're running 4. You know, we want a hot air in there. We're going to go ahead and get rid of that hot air using refrigerant as a medium. And instead of taking it to the outdoor unit and dumping the atmosphere, we're now taking this through this header. Open up solenoid valves to now take and use that unwanted space and be able to use it to help heat the area that might need that heating call and vice versa. And this is why this box is so important and why this box allows that simultaneous operation because of these solenoid valves, because of these double pipe heat exchangers that facilitate long tightening. We're able to control that refrigerant flow and also use byproducts of particular areas. Basically, for areas that need cooling, we're taking them hot air and giving it to somebody that needs heat. Now, all of these are calling for the same mode, and we don't need to recover anything, so we're just going to take that unwanted heat and discharge it in the atmosphere like we typically would with the system that is running in cooling, and therefore vice versa in heat. So it all depends on if we have that simultaneous call. If we're all calling for heating, we're all calling for cooling, we're really not doing much heat recovery. But when we have the simultaneous call, that's where the efficiency and the logic and the brains of these systems come into play with operating and controlling the solenoid valves. So let's take a look at our indoor unit product lineup. So just like with the carrier cell system, we have our cassette styles, a 2x2, which is issued right here, is our compact cassette, and right above that is our 3x3 cassette. We have our traditional high wall style. We have our under ceiling horizontal or that little purpose unit. We have a vertical air handling unit with optional electric heat as well. We have our ducted style units, which are low static, medium static, and high static style ducted units. So all in all, we have 9 different indoor unit types that'll range from 7,500 all the way up to 96,000 units of capacity. Now, of course, depending on what indoor unit you're working with, it's going to be determined minimum wise of what you have. For example, we'll range down to 7,500 meters. The high static unit, the small capacity we have on it, is 3 tons. All derivative of working. They're all 208, 230 single phase applications. Just like we stated before with the carrier product, integral ventilation and condensate lift mechanisms on most of the models. So the cassette style units have outside air integration, condensate lifts, low static, medium static, integral ventilation, condensate lifts. High static, of course, we have integral ventilation, but does not come with a condensate lift. Neither does the high wall, vertical air handler, or under ceiling have the ability to have the condensate lift, and only outside air handling with our vertical air handler. And we stated in the previous product offering, the outside air must be pre-treated prior to entering into the raw, untreated outside air. So one unique advantage that we have with the sheeted carrier system is what we call our DLS Interface PMV controller. When we talk about PMV, that acronym stands for pulse motor or electronic expansion valve, commonly referred to as PMV. Okay. And what we can do with the DX PMV kit is we can take and integrate into a third-party air handler with a custom third-party coil utilizing this PMV kit for that refrigerant to fit into an existing air handler while being able to type in other traditional VRF indoor units such as the cassette and ducted style unit that we see here in this depiction. So what we're essentially using is PMV kit or this refrigerant management kit paired with some form of controller, so we can operate off of a 0 to 10 volt signal, or more commonly operate off of. So we need both if it's to work in unison, plus the custom third-party coil that's developed depending on the capacity that we need to fit in to this air handler that we're trying to remedy. So essentially, we're taking and converting that wasn't heat recovery into heat recovery. So as I stated, we have 2 separate DX controllers. The first option is going to be working on the 0 to 10 volt DC input, or more commonly working off of the return air. And then of course we need to pair that with a PMV controller or an expansion valve kit to help manage that refrigerant. And again, it will be based on what type of tonnage coil that we're going to need. Again, we get a custom third-party coil that will not fit into the existing coil that's in the air that we have. So let's talk about controls. So just like we talked about in the carrier system, we have 3 different styles of controllers. We have a local or zone controllers such as wired or wireless. We have our centralized system controllers. And then we have our pump level system controllers, or alarm-based. So with our most common wire wall control, this is going to be RG57. This essentially is the same thing that you would see with the carrier cell system, except now we're working with the sheeted carrier product. So we still have the mode, things changes, on and off. We have stable timers with set points, we can lock down keys, so we can press buttons, we have a set temperature range limiting, and we also have the advanced function on these wire remote controllers where we can do in such as cool temperature, troubleshooting process, or a maintenance process to confirm that the unit is in fact giving what it's supposed to do. We have our centralized control, which each one of these TCS net relay interfaces, which converts this Toshiba carrier protocol over into how we can interpret it on the touchscreen controller. Each 64 indoor units. If we have multiple systems and more than 64 indoor units, all we do is gauge the second net relay interface, which can feed on a common control line back to the centralized control. So it's important to know we have over 64 indoor units total between multiple systems for two of these net relay interfaces. So we look at combining interface integrations. This is where we start getting into recovery level control. Specifically focusing. If you have a job or a fitting job, designing job that has carrier rooftop equipment, or ductless equipment, and carrier VRF equipment, all of that can be brought in to our ideal control system. Now, the VRF system more specifically can be brought into our ideal control system with our pre-packaged ideal interface. So this ideal interface has built-in logic and programming, so essentially it's a plug and play as far as integrated controls, and also having graphics on there that display for the indoor units. So this is the easiest thing that we have as far as integrating carrier VRF into a carrier IVU system. Now we can set this up multiple different ways. We can set up grouping based on floor, area, tenant, level, depending on the application. We can remotely access and turn the system on and off. We can enable and disable our local controllers or our wired wall controllers if we're running into an application where someone is adjusting the thermostat out of the range of where we would like it. We can display alarms and then provide history alarms, which becomes crucial for when we get multiple service calls for the service guy trying to troubleshoot properly diagnose and repair an issue. And we can connect a maximum of 64 indoor units per IVU interface with a maximum of 16 different refrigeration systems. So if we go over that 64 indoor units, we can add a secondary IVU interface to report back to the IVU system. Okay, so we talked about a lot. We talked about our Toshiba carrier heat recovery and heat pump. We talked about our carrier heat recovery. So let's try to summarize this the best we can. So let's look at the Toshiba carrier advantages. We talked about having a true hot gas line, or where that separation process occurs, which is the outdoor unit, which is why we call this on the heat recovery pre-pipe system. We have flexible piping solutions on there with multiple different styles of selector boxes, single port or multi-port that you can have. Our PMVs or EXVs, when our indoor units are shut 100%. We have lower turn down with rotary compressors, which is one of the reasons why the rotary compressors are utilized with these PMVs that are shut 100%. More efficient, at lower frequencies with our rotary style compressors. And we have single phase heat recovery and heat pump option depending on residential and low commercial application. And then carrier advantage. So we have our single point connection for power, communication, and control. And also pipe. We have a centralized location for a changeover box, and we have options of total ports that you can have. So with the Toshiba carrier, those multi-port boxes have a 4 or 6 port configuration, while the carrier system has a 6 through 16 port connection on their box depending on the application. So we can facilitate more indoor units and locate that box centrally. By having that hub and spoke communication wiring from the NDC to the indoor units, so we can essentially follow our refrigeration pipe from port 1 to indoor port 2 to indoor unit 2, so they're not dealing with that daisy chain, and it essentially eliminates some of the complexity with control wiring on these systems. And of course, we have our single phase heat pump offerings for like commercial applications. So it's not that Toshiba carrier is better than carrier, or a carrier is better than a Toshiba carrier. These systems have their unique applications. They also have their unique advantages and disadvantages, which is why we have both to be able to fit a wide variety of applications and to ensure we have the correct style of VRF system for your application to meet your customer applications. So let's go ahead and take a brief look before we let you guys go here. Our job profile highlights. So essentially what this is a brief job highlight overview of some more recent jobs that Standard Air Lite and myself start it up, help design, and work with our installer contractors on it. So our first job on here is going to be one of my personal favorite jobs, and one I'm very proud of. Be affiliated with, be able to start up, be able to work through a window just because of the notoriety that the company has. But this is through a window further HQ. So on our first phase, we had 3 28-ton recovery units with a total of 43 indoor units between those 3 outdoor systems. We have a mixture of high wall units, set units, ducted units, and floor consoles. For controls, we have all programmable wired remote controllers for each indoor unit. And the outdoor unit then sends that data to our backend interface, which is set up with a custom program that is integrated into a system that is controlling the entire building between rooftop units, VRF units, and outside air units. Okay. Currently, we have phase 2, which is 4 28-ton machines that we're dealing with. Currently, 3 of them are started up. Probably within the next month to finish up phase 2. But this is certainly a job that Standard Air Lite is happy to integrate with and happy to provide a complete system that would be very nice. Second one is going to be Duffy's Beer. The South Hill, Duffy's Beer is certainly one of the more unique distributors. We haven't done it for a suggestion you go because it is essentially a giant warehouse for the quantity supply of beer. It's a really unique place. We're certainly fortunate to have the opportunity to work with the contractor on the design and build system to provide them with heating and cooling that they never had. And the issue was that they were losing business because of the unregulated temperature throughout the space. And essentially what they had was exhaust fans to try to exhaust hot air in the summer. And of course in the winter it was just too cold, people were staying and weren't purchasing the product. So they were certainly looking to invest in a system that would allow customers to be comfortable while they're in their store shop. So what we did here is we have 2 24-ton heat pump systems with 19 different cassette style units. These are 3x3 cassettes. And 22 wired programmable wall controllers. So nothing really fancy about this application. All open concept, which is why we went with heat pump style system. It's the same thermal load, so there really was no piece of the product. Certainly one Standard Air is proud to be part of. And then finally, more recently, in the beginning of this year, DLS, this is a new building that was built over in the South Point Office Center over in Washington, or excuse me, Annenberg, PA. So this system is comprised of 2 16-ton heat recovery systems. We have 18 UV static ducted units with UV lamps, of course, with COVID protocols and making sure that we're providing healthy air for the children that will be here for the learning academy. We have 1 set style indoor unit and then 2 floor console styles that handle the stairwells that go between the first and second floor. And then for controls, we have 1 touchscreen centralized controller program to send alarm notifications if a unit or a system goes down to ensure that that system gets addressed as soon as possible. Given that we have children in there, we want to make sure that the environment is comfortable, as well as being forced to utilize as well. Just as a ending note here, if you're ever interested in coming in and learning a little bit more about this equipment hands-on, we do traditional classes, which are 4-hour classes, which go over Toshiba products, carrier products, ductless products, and we also do workshops which utilize this lab for a more hands-on experience for the guys, and also for the engineers as well to come in and actually see the equipment for themselves, feel it running, get more familiarized with it. So please feel free if you have any questions, comments, concerns, please feel free to reach out to me. My information, my email, office number, and direct extension are listed on this slide. Appreciate you guys taking the time. Hope you learn a little bit more about our carrier and Toshiba carrier VRF products, and look forward to seeing you guys next time.